All right, so we're going to revisit this absolute value function. And remember, an absolute value is just the positive number of whatever's in the brackets right here and right here. Right? So whatever you have inside these, not these brackets, but these absolute value lines, you turn it positive, whether it's negative or positive. It represents like the distance from something, right? If I'm 5 miles to the northeast of the store and my friend's like 5 miles to the southeast of the store, we're both still 5 miles away. And that's kind of like the concept of absolute value. Well, what does a function look like? As a reminder, just going to use what functions do and how they work to plot it. All right. So I'm going to put my x is -6 there, and for everywhere I have an x, I plug in -6. Right. So this is going to be y, or my y value. I'll just put it up here as a new thing. So this is how y equals this stuff. All right. So I'll make a table like this, I guess. Okay. So y equals, all right, so it's going to be the absolute value of -6 plus 3 minus 1. All right, so -6 plus 3 is -3, so that's 3 minus 1, all right, which equals 2. So that's 2 right there. So at -6, my y value is 2. Okay, so if I have a -5, all right, it's going to be -5 plus 3 inside my brackets minus 1, so that's going to be -2. That's going to minus 1, the absolute value of -2 minus 1, which is going to be 2 minus 1, which equals 1. So at x is -5, y is 1. Okay, so now let's do -4. -4 is 1. So -4, it's going to be 4 negative plus 3, which is going to be -1, but that's going to be minus 1. But remember, the absolute value is -1, so it's actually 1 minus 1. So it's going to be 0. Equals 0. Okay, so now this is going to be at -4, y is 0. And then a -3, I have the absolute value of -3 plus 3, which is 0, absolute value 0, 0, and that's going to be minus 1, so it's going to be minus 1 right there. Okay, and you might come to find out that -1, when this absolute value is 0, minus this 1, it becomes an important number. Okay, so now let's do -2. So when -2 plus 3, right, that's going to be 1 minus 1, it's going to be equal to 0 again. So at -2, it's back up to 0. And then at -1 plus 3, right, it's going to be equal to -2, or sorry, 2, positive 2, which is the absolute value of that is 2 minus 1, so that's going to be 1 again. So here I'm going to be 1. And then my y-intercept, when x is 0, right, it's going to be 3 minus 1, which is 2 right here, my y-intercept. Right, so this looks like, just like every other absolute value function, it looks like a v. Sometimes they're upside down if it's a negative absolute value, right, but this is a positive absolute value. So this is going to look like that to my vertex. Vertex aren't only applicable to parabolas, right, so it's going to look like that, right, on my graph. Let me zoom out, finish the rest of this stuff. I'm already zoomed out. Okay. All right, so what's the vertex of this? Well, right there is my vertex. This is my vertex, so I'll call point V. Right, so my vertex equals the x value. That's going to be the minimum of this whole thing. The minimum at -3 and -1. Okay, the equation of symmetry is the line that lies on my vertex. The x value that lies on my vertex, which is x equals -3. It's right there. Okay, what are the x and the y-intercepts? Well, there's a y-intercept right there. Right, my y is 0, which I said was 2. I forgot to write it down, but that's my y-intercept. because x is 0. And then these zeros here, those are my x-intercepts. Right, so my x-intercepts are 0, -4 and 0, and -2 and 0. Okay, and my y-intercept is right there at 0 when x is 0, y is 2. Okay, so the domain of this thing, where does x exist? Where does a value for y exist when I'm going left and right? Okay, so this goes infinity that way and infinity that way. That means the domain for this is a set of all real numbers, or all numbers of x such that it's all real numbers. That's good enough for me. Real numbers. Okay, and then what about the range? The range is a value of y. So where does y exist on this line, or where can y exist on this line? Well, I'm not gonna have any value of y below my minimum point here of my vertex. So my y value, my vertex was -1, right? So the range of all values of y is such that y is greater than, but it can be equal to -1. Okay, and then here, identify the intervals at which this function is going up or going down, right? So it's going down from here to my vertex, right? So it's got a downward slope from here to my vertex, and it's got an upward slope from here to my vertex. My vertex is going to be the domain for its increasing in the values of x, such that x is compared to what? X is compared to my x value of my vertex, which is -3. And when x is greater than -3, right, is greater than -3, it's going to be going up. It's going down at all values of x, such that x as compared to -3, x is compared to -3, and it's on that side. So it's going to be like that. Okay, so that's how absolute values functions in their work and the different features of these things. It's negative between here and here, and it's positive from here to here. Okay, so that's how that works. I hope it helps.